Good morning, dear students. We'll start the new module, that is module number 4, infinite series. Introduction. What is infinite series? We'll see now. It is basically a summation of infinite number of terms. The summation will be meaningful if there is no significant change in the sum, as more and more terms get added up, which is the concept of convergence. We discussed the aspects of convergence and divergence of an infinite series of positive terms which are attributed as the nature or behavior of infinite series. Means already you have seen series problems in your high school level. So here we'll see the given series, it is going to be converges or diverges according to the behavior of the, or I can say the nature of the infinite series. So here definition: if u1, u2, u3 so on un be an infinite sequence of real numbers, then, so definition: if u1, u2, u3 so on un be an infinite sequence of real numbers, then u1 plus u2 plus u3 plus so on un plus so on till it will go infinity is called an infinite series, because u1 so on till what here? Infinity. So we are going to consider what here? It is infinite series. Infinite series is denoted by summation of un. Remember this, it is denoted by summation of un, and sum of its first n term is denoted by Sn. Means first n term means it will come u1 plus u2 plus u3 plus so on till only un. So I have written here Sn is equal to u1 plus u2 plus u3 plus so on un. So first n term is going to called as what here is denoted as Sn, and u1 to infinity is going to consider as what here? Infinite series. So these are the two notations, summation of un and Sn. Sn will be what here? It is sum of first n term of our what here? Infinite series. So these are the two things we need to remember here. Now we'll see the important concept here. Those concepts are convergence and divergence. We have two important concepts, convergence and divergence. So here we'll see when the given infinite series is going to become convergent or convergence, or when it is going to be divergence. Consider the infinite series, that is summation of un is equal to u1 plus u2 plus u3 plus so on un plus so on to infinity, and let the sum of the first n term, already we have seen, it is Sn is equal to u1 plus u2 plus u3 plus so on up to un. Then a series summation of un is said to be convergent, is said to be what here? Convergent if limit of, okay, just concentrate, limit of Sn as n tends to, this is what here? Sn as n tends to infinity is equal to L, where L is a finite quantity. Means this is a finite number. Second one, a series summation of un is said to be divergent if limit of Sn as n tends to infinity turns to what here? Plus or minus infinity. So two cases are there. So what is divergent, what is divergent, and what is convergent? If turns to what here L, where L is finite quantity, or it is what here plus or minus infinity, is going to called as what here divergent. This is a general definition of convergent and divergent. Here we want to just highlight the few things which one already you have learned in your high school level, that is geometric series, that is geometric progressions and all you have studied. Let us consider the geometric series, that is A plus AR. I have taken the summation A plus AR plus AR square plus next is AR cube, so on, for various values of R. The sum to n terms of this series means nth term of A plus AR square plus so on is nothing but what here Sn is equal to A into 1 minus R raised to n divided by 1 minus R if R is less than 1. This formation will come, will give equation number 1, and Sn is equal to A R raised to n minus 1 divided by R minus 1 if R is greater than 1, equation 2. So if it is R is greater than 1, R raised to n minus 1 will come. If it is less than, so it will going to consider what here A into 1 minus R raised to n. Just see the differences here. Now if mod of R is less than 1 and R raised to n tends to 0 as n tends to infinity, then our equation 1 we have what here, it will become limit Sn as Sn tends to infinity is becomes what here, if you apply limit to the equation number 1, it will become A, because R is becoming what here, R raised to n becoming 0. So what happens here, 1 minus R raised to n, so it will become A upon 1 minus R into 1 minus 0, so which is nothing but what here A upon 1 minus R, which is a finite quantity, which is here whatever we have, it is a finite quantity. Similarly, hence the geometric series is convergent for mod of R less than 1. Next, if R is greater than 1, from equation 2, the limit Sn as n tends to infinity will come out here. If you apply, so n tends to infinity, so infinity minus 0 is infinity, again infinity into anything is what here, infinity itself. So what we can say here, so this result is going to be turned as what here, divergent. So therefore hence R greater than 0 as R raised to n tends to infinity, then A upon R minus 1 is a positive quantity, so we can say that it is always greater than 1, so it will turn to what here, divergence. So these are the few little bit basic concepts of infinite series in the form of divergent and convergent. Now we'll see test for convergence of series. In this we study various tests for a series of positive terms which will be used in deciding whether the given series is convergent or divergent. So for our syllabus we have the following two tests. One is Cauchy's root test and second one is D'Alembert ratio test. Now we'll see the test number 1, that is Cauchy's root test. So Cauchy's root test says if summation of un is a series of positive terms and if limit un raised to 1 upon n as n tends to infinity is equal to L, which where L is finite here, then the series is convergent if this L is less than 1, and divergent if this limit result will be what here, greater than 1. And suppose if the result become 1 here, that is L is equal to 1, then we can say that the test is fails. So these are the important points we have to remember. What Cauchy's test says here, so it is limit of un raised to 1 upon n, it is as n tends to infinity. You are supposed to get L, but L should be out here if it is less than 1 convergent, greater than 1 divergent. If it equal to 1, test fails. Now we have one of the important note to simplify the examples based on Cauchy's root test. That note is note number 1. To apply Cauchy's root test, un is of the form function raised to function, that is function of n raised to another function of n. Point number 2, the following standard limit will useful. If you found limit n raised to 1 upon n as n tends to infinity, you can directly write it as 1. Limit 1 plus 1 upon n raised to n as n tends to infinity, if you found, you can mention it as it is nothing but e. Next, third result, where e belongs to the value 2.7 and 2.7 is what here, greater than 1. So if e comes, we can blindly say that it is divergent, because 2.7 is what here, greater than 1. If it is greater than 1, divergent. If it is less than 1, convergent. If equal to 1, what here, it is test fails. Now third result, limit 1 plus x upon n raised to n as n tends to infinity is equal to e raised to x. We can say the result. So these all three results we should remember while solving the test here. Now we'll see the example how to solve Cauchy's root test. So problem number 1, test for convergence this series summation n cube upon 3 raised to n. So already they have given the nth form, so no need to prepare nth form. So given summation of n cube upon 3 raised to n. So here I can say that our un is what here, n cube upon 3 raised to n. So this is the given un. So what Cauchy's root test says here, it is limit of un raised to 1 upon n as n tends to infinity, which is equal to, so we'll replace the value of n here, un, limit n tends to infinity, this raised to 1 upon n will keep as it is. So un, what is un? 3 n cube divided by 3 raised to n. It is n cube divided by 3 raised to n. So we'll simplify. So it will become out here, limit n tends to infinity. So n raised to n will separate the powers here. So what happens? N cube raised to 1 by n divided by 3 raised to n raised to 1 by n, which is equal to limit n tends to infinity. So this will become n raised to 3 upon n divided by 3 raised to n upon n. So this n cancels. So what left here, which is nothing but limit n tends to infinity. So 3 n raised to 3 upon n divided by 3. So this 1 by 3 will keep out of the limit, limit n tends to infinity. So what I will write here, it is n raised to 1 upon n whole raised to n, and So as we know that limit n raised to 1 upon n as n tends to infinity, already I have given the one of the formula here in the explanation. So limit n raised to 1 upon n as n tends to infinity is nothing but 1. The same thing will apply here. So limit, if you apply the limit here, it will become what here, limit n raised to 1 upon n as n tends to infinity. So I will write here 1 by 3. So this result completely will become what here, 1 raised to 3, because limit n tends to infinity of n raised to 1 upon n is equal to 1. So therefore I can say that limit un raised to 1 upon n as n tends to infinity will become 1 by 3, which is less than 1. If it is less than 1, if it is less than, means result is less than 1. If it is less than 1, what we can say, it is convergent. So therefore we can say that the given series, therefore the given series converges by Cauchy's root test. So in this way we need to simplify the examples based on Cauchy's root test.